In the remote Siberian taiga of June 1908, an unprecedented explosion shattered the silence, leaving devastation that would baffle scientists for decades. As I recall, the event's mystery and magnitude captured the world's imagination, prompting urgent questions about Earth's vulnerability to cosmic visitors, promising a story filled with awe and scientific discovery. Before 1908, Siberia was a vast, sparsely populated wilderness under the Russian Empire's distant gaze. The region was known for fur trapping, indigenous communities, and isolation. Innovations like the Trans-Siberian Railway were in progress, but many regions remained untouched by modern advancements, setting the stage for this extraordinary event. Weeks before the explosion, reports of strange lights and meteoric activity appeared. Local villagers observed unusual sky phenomena, bright streaks or glowing objects, yet these signs went largely unnoticed by scientific circles. The atmosphere grew tense with anticipation, though few understood the significance at the time. On that fateful morning, a blinding flash lit the sky. A colossal explosion erupted as a fiery object detonated approximately 5 to 10 kilometers above the Earth. The roar echoed across the Siberian forest, and shockwaves radiated outward, felt even by distant observers. It was an instantaneous event that shifted all perceptions of nature's power. As the blast subsided, the local population was bewildered. Some ran into the woods to investigate, others sought safety. The roaring wind and seismic tremors disrupted daily life. Remote communities, initially unaware of the scale, began reporting fallen trees and mysterious fireball remnants, sparking alarm and curiosity. Over the following days, reports reached scientific institutions, though technology was limited, detailing vast areas flattened like a giant's footprint. The event challenged existing ideas about cosmic impacts and prompted urgent scientific investigations, with experts eager to understand this unprecedented phenomenon. Yet the true nature remained elusive for years. Scientists from St. Petersburg and abroad arrived months later, their first impressions of the scorched earth and fallen trees astonishing. They collected samples, measured shockwave patterns, and studied seismic data, laying the groundwork for understanding this cosmic collision. Their careful analyses would take years, but the initial expedition marked a pivotal moment in impact science. Some proposed a volcanic eruption, others speculated a meteoroid or comet. The suddenness and scale of destruction defied natural explanations known at the time. Rumors spread, and the event became a subject of international intrigue, fueling debates about Earth's vulnerability to celestial threats and the importance of planetary defense. By 1927, findings from movement and shockwave analyses pointed toward an enormous object disintegrating midair, an airburst, rather than an impact crater. The absence of a crater reinforced this hypothesis, suggesting that the object exploded at high altitude, releasing an energy equivalent to dozens of Hiroshima bombs. This realization revolutionized our understanding of impact events. Scientists around the world began studying Tunguska as a modern impact event prototype. It served as a wake-up call about potential threats from space bodies. The event prompted the launch of impact risks research, contributing to planetary defense initiatives and advancing our knowledge about airbursts and asteroid threats. The Tunguska explosion ignited a surge in asteroid research. Scientists considered the possibility of future events, an unanticipated hazard, and emphasized the importance of tracking near-Earth objects, leading to the development of early warning systems and space observation programs that continue today. The event underscored the need for planetary defense, impacting policies and scientific priorities. It also revealed the potential for catastrophic damage from relatively small cosmic objects, and emphasized the unpredictability of such events, prompting ongoing research into deflection methods and impact mitigation. Local Nenets, Evenki, and Evenki communities held stories of lights and fire in the sky long before 1908, emphasizing a deep cultural awareness of celestial movements. These traditional tales preserved ancient interpretations of cosmic events, adding a spiritual dimension to the scientific understanding of Tunguska. Residual effects persisted for years. Unusual tree growth patterns, reforestation changes, and possible subtle shifts in the local ecosystem. The impact zone still holds scientific interest, offering clues about the long-term ecological consequences of cosmic impacts. From books to movies, the event captured imaginations worldwide. It became a symbol of cosmic danger, inspiring fictional stories about alien invasions, apocalyptic scenarios, and the search for extraterrestrial life, all reflecting society's fears and curiosity about what lies beyond Earth. Despite decades of searching, no definitive meteorite or fragment was recovered, suggesting the object disintegrated completely at altitude. This mystery continues to challenge researchers and fuels speculation about planet killers and the nature of celestial debris traveling through space. The explosion provided crucial data for impact physics. Researchers developed sophisticated computer models to simulate airbursts and asteroid behavior. Tunguska became a benchmark for understanding impact dynamics, shaping current planetary defense planning and risk assessment practices. While most evidence points to a stony asteroid, some proposed a frozen comet nucleus, given the high-altitude explosion and compositional clues. This debate highlighted the complexities of classifying cosmic objects and the importance of detailed spectral analysis to determine their origins. Today, many countries maintain observatories dedicated to tracking near-Earth objects. Tunguska remains a catalyst for these systems, emphasizing timely detection. International efforts continue to improve early warning capabilities, aiming to prevent or mitigate future impacts similar to 1908. The event accelerated technological innovation, improving seismic detection, satellite surveillance, and impact modeling. It also inspired educational programs about space hazards, fostering a new generation of impact scientists dedicated to safeguarding Earth. Tunguska demonstrated Earth's vulnerability while emphasizing the importance of planetary defense. Its lessons have driven policies and research worldwide, highlighting that cosmic hazards are not science fiction, but real risks demanding our attention. In Siberia, memorials honor the victims and the land's resilience. The event is commemorated by researchers, local communities, and international organizations, ensuring that the lessons learned remain central to our understanding of cosmic impacts and the need for vigilance. Government agencies and international bodies integrated Tunguska's lessons into disaster preparedness plans. It served as a catalyst for impact warning protocols, shaping a global framework aimed at early detection and response to potential asteroid threats. Despite over a century of study, Tunguska remains partly shrouded in mystery, especially regarding the exact composition and origin of the object. Its legacy endures as a symbol of cosmic unpredictability and the necessity for continued vigilance and research. Recent remote sensing, satellite imagery, and spectral analysis have provided new insights, refining impact models. These advances exemplify how modern technology continues to unlock secrets from the Tunguska event, inspiring ongoing investigation and understanding. By illustrating the destructive potential of extraterrestrial objects, Tunguska broadened perspectives in astrobiology and planetary sciences. It supports the search for meteorites and impacts beyond Earth, informing theories about planetary evolution and biological resilience. Tunguska serves as a stark reminder that space is a domain of both wonder and risk. Ongoing exploration and mission development aim to identify and mitigate cosmic threats, emphasizing that humanity must stay vigilant to protect our future. Tunguska galvanized nations to collaborate on impact risk assessment. Shared data, joint missions, and global watchdogs exemplify how planetary defense fosters peaceful international cooperation, driven by a shared understanding of cosmic threats. Schools, museums, and media highlight Tunguska to educate about space hazards. Such outreach nurtures awareness, inspiring future scientists and policymakers to prioritize planetary health and resilience against cosmic impacts. The Tunguska Event reminds us how fragile civilization can be in the face of cosmic forces. It prompts humility, resilience, and preparedness, lessons that extend beyond science into ethics, governance, and our collective responsibility to safeguard Earth. Decades after Tunguska, its lessons ripple through policy, science, and culture, inspiring a legacy of vigilance and discovery. Humanity's recognition of cosmic hazards leads to ongoing efforts to protect our shared future from the unpredictable reaches of space. The Tunguska Event remains a profound lesson from Siberia, reminding us of nature's immense power and our duty to study, prepare for, and respect the cosmos. Its legacy continues to shape planetary defense efforts and scientific curiosity across the globe.